How do you find the derivative of the sum of two functions? Well, you already know how to do that. I'm going to find the derivative. So f prime of x equals the derivative of the first function. This is an exponential function, so the derivative, of course, is ln of the base times the original function times the derivative of x, which is just 1, so I won't even bother writing that, plus the derivative of the second function. Now I'll use the power rule for this, so that is 15x to the fourth. So just to be clear, the derivative of the sum of two functions is just the derivative of the first function plus the derivative of the second function. Now things get a little bit more complicated when we find the derivative of the product of two functions. So hang in there. I'm going to go over the product rule and then do 3 examples. The product rule states that to find the derivative of the product of two functions, now I'm calling my functions a and b, it is the derivative of the first function, I'm calling that a prime, times the second function, that's b, plus the first function, a, times the derivative of the second function, b prime. Now, I'm not going to go over a formal proof of this, but I think it's nice to have a visual sense of what's going on. Imagine that a and b represent the sides of a rectangle. So a times b, of course, would be the area of this rectangle. Now imagine I'm stretching the rectangle in the horizontal direction, so a is changing, the length of a is changing, and I'm stretching it in the vertical direction here, so b is changing. Right? And a derivative is really a description of how something is changing, right? It's the instantaneous rate of change or the slope of something. So my derivative represents the change in the area of this rectangle. So let's think about how the area of this rectangle must be changing. So remember, my rectangle is being stretched in the horizontal direction. So I'm representing that with this little sliver right here. This little orange sliver represents the change in area as I stretch it in the horizontal direction. And I'm calling this little slice the change in a, right? A derivative is really just how something is changing. So this is how a is changing times b, right? That's the area of this little orange rectangle. And the rectangle at the bottom represents how my area is changing when I stretch it in the vertical direction. Now this little amount right here is just the change in b times a, length a. So how could I describe the change in my rectangle's area? Well, clearly it's just the sum of these two little orange slices. Well, this is just a prime b plus a b prime. Hey, that's the product rule. So hang in there, we're going to do 3 quick examples. Let's use the product rule to find the derivative of the product of 2 to the x times 3x to the 5th. And I'll call this first guy a and the second guy b, and I'm going to use the product rule. Here we go. The product rule says take the derivative of the first term, I'm calling this a, so a prime, now of course this is an exponential function, so the derivative is ln of 2, right, ln of the base, times the original, 2 to the x, times the derivative of x, which of course is 1, so that's my a prime, times b, now b of course is just 3x to the 5th, I'm just copying over this piece exactly as it is, plus the first guy, a, so this is not the derivative of a, it is just a, which is 2 to the x, times the derivative of b, right? That's my b prime. So the derivative of b, of course, I'm just using the power rule, is 5 times 3 is 15x to the 4th. And that is my derivative. I have used the product rule to find the derivative of these two functions being multiplied. Hey, they're a product. All right, 2 more examples. Let's use the product rule to find the derivative of the sine of x times the square root of x. So I'm calling this first part here really a, and I'm calling this b. And the product rule just says, to find the derivative of the product of these two terms, I just take a prime, which of course the derivative of sine of x is cosine of x, times the second term, that's just the square root of x, plus the first term, which is the sine of x, times the derivative of the square root of x. Now the square root of x is really the same thing as saying x to the 1/2. So its derivative, I'm just using the power rule, right, is 1/2 x to the negative 1/2. And that's really it. Now, I could rewrite this as a positive exponent if I wanted to. So let me just do that. So that's cosine of x times the square root of x plus the sine of x. And if I wanted to write this as a positive exponent, that would just be 1 over 2 x to the positive 1/2, or I guess I could write that as square root of x. And that's all there is to it. Let's do one more example. For this last example, I just want to convince you that the product rule actually works. So I'm going to use the product rule to take the derivative of x times 3x squared. Now, of course, you could multiply these together and then take the derivative that way if you wanted to, right? Of course, this is the same thing. X times 3x squared is the same thing as just saying 3x cubed. And of course, the derivative of 3x cubed, and I can do that right below, is 9x squared, right? I'm just using the power rule. So if I use the product rule, I better end up with this as my derivative. So here I go. The product rule says take the derivative of the first guy. So my derivative, f prime of x, is the derivative of this term, a prime. The derivative of x, of course, is 1, times the second term, that's 3x squared, plus the first term, which is x, times the derivative of this second term, which of course I'm going to use the power rule for, that is 6x to the 1. All right, now let's just multiply everything I have together here. So I have 1 times 3x squared, which of course is just 3x squared. I'll write that down. I have 3x squared, x squared, plus this is of course 6x squared. And when I add those together, I get 9x squared. That is my derivative. So I can see that the product rule works, but even more than that, I can see that if I just take the derivative of each piece and try to multiply them, it doesn't give me the right answer, right? The derivative of x by itself, so let's say I just tried to do that. The derivative of x is just 1. The derivative of this term is just 6x. And if I just multiply those together, I end up with, I'm multiplying here, I end up with 6x. Well, clearly the derivative is not, that's a not equal 6x. So in order to find the derivative of a product, you must use the product rule. It won't work if you just find the derivative of each piece and then try to multiply them together. So hopefully that makes sense. Now it's your turn to try a few.